Welcome to Chapter 3. Chapter 3 is about the normal distributions. So a normal distribution is that bell-shaped curve you've probably heard about at some point in your life, and we're going to look at that in a lot more detail in this chapter. So before we get started, a couple of quick housekeeping notes. There are two pre-quizzes for this chapter, and then we'll also be using Excel at the end of the chapter. So you're going to want to check the data ribbon, make sure that you still have the data analysis and solver packages on there. Sometimes when Excel updates, they just seem to go away. So double check and make sure you have them. And if not, they're pretty easy to add back on. There are instructions on Canvas. There's a link on the Chapter 3 page, as well as there's a whole page that's just dedicated to Excel that also has that information on Canvas. But if you run into any problems, just reach out and let me know, and I'll try and help you figure that out. All right, so we're going to start by defining a density curve and a probability distribution. So those are some pretty big, heavy words. Let's kind of break down what's going on here. So a density curve describes the overall pattern of a distribution. So this is something we've kind of talked about before in this class, whether a distribution is skewed or symmetric, whether it's uniform, unimodal, bimodal, those kinds of things. Okay, so this idea is going to be related to that. The way that this works, you're going to plot the possible values of the variable on that horizontal or x-axis. So for example, if I was rolling two dice, the smallest number I can get is a 2, so my distribution would start at a 2, and the biggest I can get is a 12 if I'm rolling two standard dice. So my distribution would go 2, 3, 4, 5, 6, 7, all the way up to 12. And then on the y-axis, what we're going to plot is the probability that you're going to get that value. So for example, to roll a 2, I have to roll a 1 and a 1. That's pretty difficult to do. So it has a very small probability, which means where the 2 is on my axis is going to be very short to represent that small probability. If I wanted to roll, say, a 7, I could roll a 1 and a 6, a 2 and a 5, a 3 and a 4. And so there's a lot more chances to roll a 7. It's got a higher probability. So where the 7 is on the axis is going to be a lot taller to represent that probability. All of our y values or all of our probabilities are either on or above this horizontal axis. Okay, and that's because the smallest a probability can be is 0. So you don't have negative probabilities, those aren't defined here. And so we can't have anything that drops below that axis. And then the last point here is actually something that the way that we define these curves. So we define these curves such that if you add up the area underneath that curve, it's always going to add up to 1 square unit. So that would be kind of equivalent to 100% probability. Okay, so come back to the next video and we'll talk about how we get from here into the normal distributions.